And there's the Mediterranean garden too. And some of the food is I was there for. I was there for. Yeah. Anyway, some of the properties are oh, really giant diameter.
Yeah.
Piece of crunch. Where's the hook? Oh, wow. So they is that why I'm sitting here?
I'm happy to do that. I don't care.
I can try to reach it.
Yeah. So I guess since I'm here, I'll run the meeting echo.
Yeah, but
I'll do the slides.
You do the slides.
they have to go chewing
And
together.
then you're
So
going
they're not.
you're going to get up
Not
and
anywhere
talk.
else.
And I can just do the milestones. Because Ben hasn't.
Right.
Which is totally fine. I'll hit up blue sheets.
I signed this, but you guys need to put, I didn't know if it was Dell EC or Dell RSA or, I was like, oh, I better.
Dell EC.
Is it Dell EC? And then I was
Apparently, you'll have to me with no space.
Until 5 letters.
I've been using a space. I'm going to start handing out the blue sheets because we're at time, but I think the snack break maybe is impacting us a little. We'll get started in a minute.
Okay, so I guess I'm writing the first slides. I'm just going to go ahead and get started. All right, since we have a full docket, I'm going to go ahead and get started. Good afternoon, everyone. You are in the RATS working group, and it's the Remote Attestation and Procedures. We are actually meeting for the first time, and thank you everyone who helped cooperate and carry this to a working group. So before I begin, I want to thank Roman for being my co-chair during the BOF, and thank him again for being our area director. So welcome, Roman. And I also want to welcome my two new co-chairs, Ned Smith on my far right and Kathleen Smith. That's Ned Smith. No, they're not related. Can you tell it's Thursday afternoon? And Kathleen Moriarty. Okay, now we can cross.
I have an Uncle Ned Moriarty. Yeah, I do.
Okay, so given that it's Thursday afternoon and I'm already messing up, this is the IETF note well. I will not go through it. I'm presuming that by now you would have attended a few sessions and now understand the IETF procedures. So you can just click, yeah. Okay, so let's do a quick agenda bash, and I let you guys read this. As you can see from the agenda structure, we are going to be quite full. I've asked Lawrence to help facilitate the discussion for what we do with the claims definition, potentially information model at the end. So I tried to allocate as much time as possible for that discussion. So if we can defer some of those questions to the end, would greatly appreciate it. We're going to kick it off with the intent in trying to build the use cases, not that we're going to publish them as an RFC, but to help serve as a guideline, followed with the architecture and interaction models by Hank, and then some of the proposals vis-a-vis the Yang to the token bind and the EAT. So with that, any discussion questions on the agenda? Going once, twice? Okay, good. Let's go. Okay, administratively, I want to thank Stephen Banghart for being our Jabber scribe and Eric for being one of our note takers, but we could really use a second. So please, somebody, please, pretty please. Thank you, Chris. All right, so sorry, Eric. I did put the link for etherpad.tools, but Chris, can you do that? Perfect. No. Actually, if you can just do the etherpad.ietf.org, because that's what Eric is using. All right, so with that, I'm going to let Ned, since this is our first official working group meeting, I thought it would be good to just provide an overview of what we signed up for vis-a-vis the charter.
Okay, so there was discussion on the list about the charter. I'm going to overview that for you now. Basically, the high-level charter is to improve the confidence in the system components, trustworthiness that a relying party may require evidence about, and so we're listing some of these types of evidence we would expect to be exchanged in the context of an attestation. This would be system component identity, integrity or configuration information. It could be composition of the system components, where there could be nested components, and also roots of trust. It can be associated with manufacturing and assertion or claim origination or provenance. And again, some of these terms are defined in the architecture, but we had to define some of them to some degree in order to come up with the charter, but just acknowledge that there may be some ambiguities in some of these words. Attestation evidence could include operational state and measurements of steps leading to operational state, for example. It could also include factors that could influence trust decisions, so sort of a variety of other things. In terms of the goals, the focus should be on interoperable attestation, where the focus is on evidence. There's a comma missing, so it's evidence, formats, and conveyance. We want to cooperate with other IETF working groups. We've listed a few here, like SACM, SUIT, and TEEP. There may be others. This isn't intended to be a closed list. We also intend to evaluate prior work, such as work done in IETF NIA, which is, I believe that working group's closed down. There's also work done in the TCG, FIDO Alliance, Android Key Store, and there may be others. Out of scope, there was discussion on the list about what should be out of scope. We finally arrived on definition, use, and conveyance of expected values, thresholds, and procedures for evaluation of attestation evidence. There'll be some slides to help you sort of visualize what this means in the context of the architecture talk. But we did identify some out of scope areas here. So next slide. The program of work, we're going to specify use cases for remote attestation, specify terminology and architecture that enables the attestation. So this could include system security model for assigning keys, system components, component providers, and relying authorities. We're going to standardize an information model for assertion claims that have to do with trustworthiness. And I think that's an important context is in terms of limiting our scope is assertions ought to in some way relate to trustworthiness of the attesting device. We standardize data models that implement and secure the information model. And so, for example, CBOR Web Token does this, JSON Web Token. This is an example. There may be others that we want to look at. And then standardize on interoperable protocols. And I think this should say that we're not going to define protocols, but we're going to standardize on bindings to protocols to securely convey assertions and claims. So any questions? All right.
Okay, so as chairs, we had to put some milestones. They actually haven't been approved yet, which is a good thing. It's just meant to be a template. We had hoped that we could do call for adoption, so that's why if we can get through the agenda, I'd like to leave some time at the end. Based on the discussions, we can then determine whether we're actually ready to adopt some of the documents or not. So we figured the architecture draft has to align all of the work that we're doing here, so that's why we're deferring the timeline for that. As we settle in the work group items that we're going to adopt, we don't expect the architecture to be quite ready until we have that body of work somewhat stable, or at least in some known path. So the way we had laid this out is once we adopt the working group items, that it would take us about a year to get it to publication. So if we have enough time at the end, we can discuss about the timelines, but some of that will be dependent on the draft as well. Otherwise, we will continue discussing this and try to come up with something fairly quickly so that we can put it on the RATS milestones. So with that, I want to give as much time back to the presenters. So with that, let's have Michael. You're up with the use cases.
Where was the timer? Where was that timer that I had?
I gotcha.
You got my timer, okay. She says I got like 8 minutes. Next slide, please. I put together a use case document, posted it in the hours before the deadline, and 01 was posted this morning based upon the feedback I received in the list. To clarify, I think we put this in the charter as well, that this use case document, if you wish to adopt this one, is not intended to be published. It's for the working group's use only, and maybe someone will put it as an appendix to an architecture document or a solution document or something, but that's not the intention. So I've gone through the, next slide please. I've gone through the things that were called out in the charter. And I have received a number of documents on TCG, a number of pointers, a number of updates, and many of them this week. And I've tried to update things as clearly as possible. And the key thing, and we saw a presentation in 103 about, and there was a demo about some of this use. It's about operators being able to attest to the software visions running on their networks. I think that their network is pretty important because many of the other use cases are about attesting a device which is on someone else's network, which doesn't belong to you. So that's, I think, an important distinction between, I believe Hank's phone is untampered versus I believe that my home router is, you know, or my corporate router isn't, that I own, is in fact intact. Fido is more of a web-based thing, and they've done a lot of work, and if you go through their specifications, you'll find out that there's a redirect to the W3C, and I have more work to do to pull some of their stuff out, but they primarily want to make sure that the device, the end, has authenticated the human properly, and that the software that has authenticated the human properly is intact. But in converse opposite to the TCG group, they really don't care about the layers of operating system and hardware below the system so much as the layers above it into the web browsers and other things like that. Android Key Store, I believe I've been told that I have an update in the last hour pointing me to more of the interesting parts of that. Up to this point, it has looked like a, there is a TPM-like interface, and that's good. And that's all I know about it. So those are the 3 things that we've listed in our charter. I know there are probably 6 more, and I would love to hear from you, either in the form of documents or in the form of discussions or phone calls. I a little bit would prefer to, particularly if the content is under any kind of NDA, I would in some ways prefer to speak to you and paraphrase what you say rather than sign your NDA. But if you'd rather me do the other way, and then you'll have to, I'll try to exfiltrate your data, your use case out from that. I'm happy to do that part for the working group. Next slide. I think that's the last one. Discussion. There you go. Did I finish in 9 minutes?
3 and 20.
There you go. All right. So
Dave Taylor, and either an extension to the TCG one or maybe another use case of the TCG one. In your TCG description, you talked about the network operator. There's a variation of the use case where it's not the network operator, it's the device operator, right? So the device operator has, you know, a server and a device and wants to test those independent of who's running the network.
Can you give me an example
Otherwise, it's
of
the same technology.
a device operator?
An enterprise,
An enterprise. So
right? Where the part of the operations team that or manages the devices is different from the part of the organization that manages the network.
I see. In the enterprise concept, so you're saying that the guys that own the server don't own the plumbing between them and the server, but they want to make sure the server is intact. Is that what you're trying to tell me?
Or the client, correct? Either one.
Yeah. The client. Okay.
Right,
Thank
right.
you. I understand the use case now.
Frank Xia, Huawei. I'm the network device vendor. I see in the last page you mentioned different use case from different standard organization. For the TCG part, there are actually there's not only one use case from TCG. There are for PC, for the mobile, for the IoT, and for the network device. So I just want to note that at least there are some interest for the network device remote attestation use case.
So I did get, thank you. I did get some feedback from some other TCG people saying that, it looks like the document that our internal document doesn't clearly articulate that things like Linux processes are going to be attestable. And so I would prefer, I would want to receive your feedback there, and Jessica there has given me some already about this. And so clarifying which parts are in scope and which parts are not. I think what I would prefer is that some TCG people like you standing there would tell me what specifically you want in scope and what specifically you don't.
So this is Jessica Fitzgerald McKay, NSA. I'm authoring the TCG document that Michael's working with, along with Guy Fedorkow from Juniper. That particular document has a specific network equipment focus. TCG more broadly addresses attestation for other types of devices as well. We thought that was the one that was specifically in scope for RADs.
Hi, Michael. This is Hannes. I think you should change the name of the...
Hold on. So, Jess, the document is proprietary?
It is, but currently we're working with the TCG board to enable better sharing.
Right. So it would be useful if you could at least cut that snippet and put it in the mail list, just so we have it on record as well, that it's open.
Yeah, Michael has...
So I've been trying to do that and trying to, as I say, exfiltrate their use case.
But you're not a member, so
I'm not a member,
requesting
right,
a member to do that.
Yeah, and that's what I would prefer as well, is that you guys post it, because then I don't have to worry about which parts you want to disclose and which parts you don't.
Yeah, we're getting conflicting feedback from the TCG board on that, so that's what, as soon as I work through that, I'll share what I can.
Or perhaps you could indicate just the use case and the requirements as an individual without having to extract it from TCG.
This is Hannes again. I would suggest you
I was
do not...
going to cut the line at Hannes, by the way, sorry.
Okay. I would suggest you change the title of the document from use case to technology survey also, because as mentioned earlier, like they have different use cases, and even the IoT use case tends to be rather broad by itself, and you're not even describing any of the use cases. You're talking about like what did FIDO do, and FIDO actually does more now.
Thank you for that feedback, Hannes. I'm claiming the document is deficient, not the title.
Okay.
Okay, so I'm aspiring to.
So you're actually trying to get the use cases,
right?
You're not there yet.
But I'm not getting the use cases out of people. I'm getting rather, these are some components to put together to do things. Here's some Lego bricks. They're yellow, green, and orange. And I'm like, and what do you intend to build? And like, we can build anything you like, I know, but what would you like to build today? Is it a bridge or a building? Tell me, because I want to write bridge or building. Exactly what you just said. And I'm not getting that out of things at this point. And so it's my goal to get there. So your criticism is 300% well taken, and help us get there.
Right, and as part of the process, when you look at the charter, we said that the use cases were really meant to be how these claims are going to get used, not the technologies.
Yep.
Okay, so with that.
And I also wanted to capture the terminology that they use for their variety of parties, so that we could say the TCG relying party, which may be different than the Android key store relying party in terms of what assumptions it makes, right? Thank you.
Thank you. Thank you. Hank. You have 35 minutes total.
Oh my God. Hi, this is Henk. I'm trying to be concise and with high brevity, so I'm trying to aspire to that. So I will present at first a draft that exists. This is the architecture and terminology document. Next slide, please. So, and I will begin with a small recap of the last IETF, where we had our first BOF, and there was, as an intermediate solution, a diagram introduced with 3 boxes and lines between them, and there was a little bit of confusion what these boxes actually meant. They always somehow connected to all the things people were saying, but they were not really focusing the discussion. Next slide, please. So what we basically did is in the last 4 months, we on the mail list had a lot of discussions about how to map all these interesting ideas of FIDO and key stores and remote integrity verification into a simple, let's say, collapsed architecture. And so we introduced at least 3 concepts that I highlight here, which are actors. It's basically a dotted line where you put your roles in. And then these actors actually refer to the things that you are always talking about, like the device, my cell phone, your router. There's a resource manager. It could be a bank. It could be an enterprise that wants to know that the devices are healthy. And there's a supply chain entity. It could be a manufacturer. It could be a manufacturer of a component of a device. And there is an attestation service, which is basically the most essential thing we'd want to build here, because that's the service that is going to tell you, yeah, you're fine. This device, under certain policies and certain conditions, is in your scenario considered trustworthy. This then actually makes a little more sense if you have the actual roles that are placed on these actors. And there are 4 essential roles that we are working and starting with. We do not claim completeness and we do not claim correctness, but this is where we start the discussion and the definition. And this is, first of all, the attester, the thing that wants to prove to another thing or to an entity that is trustworthy. Typically, the buying party wants to know that, but how do you know that? It's very complicated. There are thousands of different things there. How do you assess that? That's why you have the asserter, which probably is, for example, the producer of the device, or some other entity, for example, a certification entity that tells you, well, this device was vetted well and is really, really, really trustworthy built. And then there's the verifier again, which is the thing that brings all of it together and tells the relying party, yes, you're okay with that device, you can talk to it, trust it, and it's trustworthy. So all of this is done between interaction between all these roles, and they are also specified as example compositions in the architecture. We call that composability. Big surprise. Next slide. So there are some fundamental principles here. We will need an information model. I think that was already highlighted by Ned in the introduction slides. I didn't know that it was come up. That we have to represent the evidence created by the attester that wants to prove somehow that it is trustworthy, or at least give indication about to verify that it's trustworthy. And yeah, it's going to interact with other things, relying parties directly with the verifier, or calling back home to the manufacturer. So in order to do that, we need the data models. There's some solution paths drafts already out there. And we want to have this flexibility with this architecture that allows us to address use cases that will emerge and be actual use cases at some point. So this is a very good process. We want to use the existing protocols that we have here in the IETF and probably somewhere else. And we want to have an integration of the emerging public key infrastructure that is required for this, because there are different level of trust flavors here, as there are different level types of roots of trusts, and those has to be taken into account. The architecture will try to elaborate on all of this, and it will try to be not too long. We hope to make it really readable. Next slide, please. So this is what came up on the email list. It was, I think, published shortly before the call for consensus for creating this working group. This is a combination of entities that are actors. So these are the things you combine roles on. And let me highlight already on this slide that we are not doing all of this that is here. The architecture will include some things and some components and actor definitions that are technically out of scope for the architecture, but in order to convey the bigger picture are required. Otherwise, you will not get why this will function at the end. Next slide, please. Then we have the actual roles. Again, it's complemented what I just said. Where we now have it, instead of device a tester, instead of the resource manager, there's a relying party, instead of a service that is remote attestation server, the verifier, and instead of the manufacturer, we call it an asserter, because the manufacturer can tell you an imprint like immutable into the device properties about it. And these properties can be conveyed to, for example, to a relying party. Next slide, please. Also, an example of composability, sometimes those roles will be complexed into a single actor. In this case, we collapsed the supply chain entities, let's call it a manufacturer and the verifying service, into the same actor. What does that mean? Now we don't need a protocol between those two. We are not interested in that in this scenario. So if there is a existing workflow out there that uses this architectural combination, of course they have no interest in creating or using protocols that are talking between an asserter and a verifier. But outside in the big world that is the internet, probably other entities want to have to do that. Next slide, please. So that's an out of scope triangle here. And it's very hard to say everything that is under the gray area is out of scope. What I can tell you is that everything that has a red dot on this diagram is out of scope. But the asserter role, most certain, is not. And probably the attestation assertions that are created by a manufacturer are also not out of scope because they will be part of the information model. So it's very hard for us in the moment to draw this demarcation line. It is really out of scope, which is really inside of scope. So the architecture will make a good effort to better highlight that. Next slide, please. So there will be relationships. We were talking about it a little bit. There are a lot of architectures already out there, starting with TEEP. TEEP has a TAM, for example. A TAM is at the very least a relying party and most likely also a verifier. And there is a device in the TEEP architecture that has a trusted execution environment. That thing most certainly is an attester. We have the PSA draft that's very new, it's from ARM, and they are defined the network and app services. That's an actor that's probably combining the roles of party, relying party and verifier. And again, it's talking to some hardware, it's getting information about some hardware. That again will take on the role of the attester. And then we have the actually best fitting thing we saw yet, that is the EAT overall system component provided by Lawrence, which has all of them in them. There's a relying party there, it's actually called relying party. There we have multiple types of entities there, from IoT device to, I don't know, automobiles, and that's what's going to be the testers. And the manufacturer is really spelled out as an actor here. And it is specifically defined as providing both the assertion definitions as also be the verifier for this assertion, at least as a source. Next slide, please. So again, in consequence, there will be overlap with other working groups when creating this architecture document. As highlighted, TEEP, with the manifest and the attestation provenance they're very interested in because they want to provision the correct TEE. That's kind of really important to them. There will be a suit manifest and the software update for the Internet of Things working group. They also have an information model, which is interesting for this work. There is the security automation continuous monitoring working group. They have an information model, but at least they have a manifest about software. And we're talking about remote integrity verification in some cases, so there will be software involved. NetConf provides a Yang module for the managed trust anchor repositories, so you can query a thing if they have trust anchors you want to rely on. And then back in the days, there was a TAMP working group that actually did already a protocol of configuring those trust anchors. Next slide, please. So there will be overlap. There are some work is already done, some work has to be combined. It all has to make sense. There will be a lot of mapping, and there will be some new terms. So we have sources for definitions, like the National Institute for Standards and Technology. Global Platform already has a big thing about root of trust out there. FIDO also defines a lot of cool processes that we can reuse. And the TCG, as we just heard, is struggling with giving us openly more information, but they have a lot of them. So all of this attestation terminally should make sense to all of them, and it should mean the same thing to all of them. Otherwise, interoperability will be an illusion, and we will attest to something that is actually not trustworthiness, and this will not work. So here is the consensus about the core vocabulary is essential. And that is why the terminology is being pulled into the architecture draft, because it is basically the basis for everything we talk about here. Yeah, terms. Next slide, please. So in the end, there is one specific terminology problem I wanted to highlight. First, we are always talking, or often talking, about claims, but the term claim is already claimed by CWT. And the things that a device can present about itself, the device characteristics, are basically assertions. They do not necessarily come with a proof of validity, which makes them assertions. If they are accompanied with a proof of validity, they become evidence. So in any case, assertions are represented as claims in CWT. So it's very easy to use every assertion we define in an information model in a CWT data format. And assertions might also be represented in other ways, data model terminology, than claims. It's important to highlight there's a difference there. I'll skip the last one. Next slide. So what is important here is not only the assertion itself, but what it means. So we have to have people bashing the meaning of the terms. And because we were always using the word claimant, and it's so strongly associated with claim, we were switching it to asserter, so we can create assertions. That's just a terminology thing for the abstraction of an architecture. The architecture has to be abstract enough to map to all the existing and to be created solutions. So we need, yeah, actually, Ned said that we need an information model, and the attestation provisioning, which relies on what are you actually attesting to, how do you find that out, is out of scope for now. This we call phasing. There will be a time when we will need this, and when we have to pay more attention and focus and time onto that topic, but not now. Next slide, please. Am I in time?
You are very much on time. Do you want to, you have 1 minute left. Do you want to allow for 1 or 2 questions?
If anyone has a question about my very, very fast talk, yeah, sure. I'm sorry that I ran through this, but I wanted to get in the timeline again.
Yeah. We'll just allow 1 question.
Gary, my name is Paul Com. If you go quickly back to slide 5, the architecture.
Sorry for not including numbers, by the way, and thank you for counting.
Yeah, I think that was the architecture slide, so maybe I did, maybe my.
Can you describe the slide?
It's a block. It's a block diagram where there we go.
Yeah.
As far as 1B and 2 interfaces are concerned, I kind of compared this to a FIDO Alliance white paper on identity federation systems that I actually co-authored. We took the approach that in that case the verifier could be the verifier was distinctly different from the relying party in the sense that the verifier could be an IDP, and we felt that that interface was a B2B interface, what you call 1B and 2. And in my opinion, we should make, as far as this working group's work is concerned, we should be very clear on what are B2B interfaces and what require interoperability between different manufacturers' equipment that may not have business relationships. I think we'll really have a lot of difficulty defining such interfaces if we go down that path. That's my opinion.
Yeah. So as a quick reply, 1B and 2 has the very big spectrum. It can range from a hash of a public key to all the evidence a root of trust of measurement can provide. So there's a big spectrum there, first of all. Also, composing verifier and a relying party is very usual. So they can be the same actor. That's very often the case. And then there would be no protocol at all between them.
Okay, we're running over. So is it quick?
Yeah.
This is a question from the Jabber. Quick clarifying question. What is the TAMP working group from the overlap slide?
Oh, that's a very good question. I should have kept that in mind. It's older. It's completed. and it's about provisioning trust anchor information, configuring the trust anchors. It's on the data tracker. So Googling data tracker, temp, and workgroup works. Sorry.
Dave Taylor, I have a clarifying question and a question, but if we're short on time, I'll just go with that clarifying question now. On the same slide, because you talk about things like, you know, CWTs and JWTs and so on the one that had, no, the one that had all the lines and the boxes and stuff. Which lines on there are you talking about as using, you know, CWTs or JWTs or whatever? Is it line 1A or 2 or both is my clarifying question.
In this case here, the assertions conveyed could be assigned, and therefore it could be a CWT assigned. The relying party would not be able to make most sense of most of them probably, and is relaying them in a secure manner. This is why I call 1B to the verifier. So that would be one path. It could be directly between attester and verifier, would be another path. And actually the reference values, that is out of scope, could in theory also be packaged in CWTs. So in theory, all of these lines could be done with a token format. I'm hesitant to call them token if they're manifests, for example, with the reference values. Probably it's more like a manifest, but the format effectively is CWT-esque.
Okay, so I think the answer was potentially all of them.
Potentially all of them.
Interface, yes.
Okay.
Yes.
So I have another question, but if we're calling time,
No,
then I'll go-
let's hold them. We're out of time. Okay, next.
Please give to the title. The title is useful. Yeah. Sorry. So we wrote something very obvious here, and that is an interaction model for challenge response based remote attestation. Next slide. So this is a thing where you challenge someone with a nonce, and they do something cryptographically and give you an answer, and by doing that, they show you that this answer was created recent. Very recent. It's called freshness. So in remote attestation, it's important that the evidence that you get is not a year old. So that would be like really useful for an attacker to give you a healthy state about a device that is basically outdated. So this procedure is very common, and it is used to provide freshness. Actually, it's recentness. So this procedure is done in many places, which is very good. And it is always re-explained over and over again with small little variation in detail, which is kind of bad. So this is why we created this small draft that illustrates how this is done. And it could be just be a standard reference if you want to do a challenge response based nonce freshness proof via handshakes. Just reference this document, highlight which of the elements you want to use there, and don't clone the normative text anymore, please. And if you are not okay with the, next slide, please. And if you're not okay with the content of this graph, if you find anything missing, just speak out, create an issue, or write on the email list and highlight that. That is very important to us, I think. Unfortunately, we already got a good bunch of feedback, like 2 sets of real thorough feedback that is additions and some modifications, and we haven't pulled that in yet, just not enough time. So it is already in the state of being improved, but I'm sure there's more. This is my last slide.
Do we have time for a question? Okay, so Roman Daily, no hat. So as we talk about protocols for RATs, can you help me understand why this would be a good starting point? Why, as we talk about from all the different protocols we might need, we need this one first?
There's a Yang module coming up that is using that interaction model, and it is a first instance of not cloning this normative text. And there will be the OSCORE protocol next, and they will use the same mechanism and will not do the cloning next. So we will show that we have 2 documents that will use the same mechanism, and then an induction.
And then when we talk about specific instances of the information model, when we talk about the token, we're going to
It is an
reference all of this?
interaction model, not an information model.
I think he's saying it's part of the interface or transport.
It is not an information model, it's an interaction model. You start with this and then you go with this.
No, I appreciate that, but on the back half of the agenda, we're actually going to talk about actual things actual claims we're talking about encoding to trade. And is the technology we're going to use to encode the actual claims going to align with this work which talks about the interfaces that would treat
Yes, it has absolutely be aligned. So the assertions included in the interaction model that are required to do it have to be mirrored in the information model one-to-one or even referenced in a way that, but that would be multiple references. We have to know how not to clone that again. But yes, they have to align exactly.
Yeah, I guess the question I was asking, does it right now, or is that future work that needs to get
There's
done?
no information model, so it cannot align.
Why don't we take that once we have work items?
Maybe I didn't
But
get the
that
question,
point
sorry.
is well noted by our area director. Okay.
So yeah, coming back to the highlighted solution draft, which is a Yang module for this basic challenge response-based remote attestation. A lot of network vendors are interested in this, as the author list shows. And next slide, please. I'm giving a very quick background about Yang because I think everybody knows what Yang is, but there's always some uncertainty. So Yang is a language for that defines data repositories for data at rest. It rests, for example, at a network device. And then it defines a set of operations to operate on this data at rest. And there are different encodings for these operations. There's netconf, there's XML, there's restconf, which is JSON, and then there's coreconf, which is CBOR. So different implementations of protocols that have all the same operations and are semantically equivalent. They're all operating on the data at rest. This is the data store. So also Yang has RPCs. You can do basically challenge response things with it. And they can create telemetry, but this is basically a site information. So if you're curious about how Yang actually works, please go to netconf and netmod and read the basic IRCs or join their working groups. So Yang is widely used and deployed, finally, and especially on network equipment and servers or virtual services. So adding remote attestation procedures on this existing management interface was a low-hanging fruit. Let's say this. Another low-hanging fruit, for example, is a talk bind. And it's also already there. Just fill in the stuff you need, for example. So the contribution of this document is we use the Yang RPCs to effectively implement the highlighted interaction model to enable a non-spaced remote attestation procedure. And we require for this, in this specific document, a set, at least one, root of trust for reporting, so that it can be a trustful proof that the composite device, network devices typically have components, is actually integer, therefore trustworthy, and is doing exactly what it's intended to do and nothing else. Next slide, please. So the current Yang module is actually already quite mature and well done and well designed. There are some requirements, so we don't only have an RPC, but we have some complementary information like identity documents and other endorsement documents that talk about the devices and the components. Those don't have to be included in the RPC. Those you can get at any time of convenience. They're basically in their own data store. But we have been told that although Yang enforces you to give semantics to every single statement in the Yang module, it's called description, that's not enough. We have to give more a glue text in the draft, how it is applied and how it's working. But that's frosting. I think that's an easy thing to do. And please look at this draft. There was some confusion about how does this really work. And if you highlight what you do not understand and just post it on a list, and we will address that. Questions to the Yang module?
I think we're running out of time. You need to
Okay,
move to the
I'm
next one.
trying hard to do 5 minutes. This is 10 minutes. So there's a variation to do remote attestation, a nonceless one. It needs something else. It's based on time and timestamps. Next slide, please. So typically you do handshakes. They're bidirectional. This is not always feasible. This approach is called time-based unidirectional attestation, and they're using an external trusted time source. This is actually defined by the IETF very long ago. It's 3161, the timestamp authority that is creating timestamp tokens for you if you want them. As a result, we can now, if due to this time that is trusted on every side, like the attester and the verifier, create unidirectional communication between attester and verifier. And there is no response required from the verifier. there are actually quite some usage scenarios that really could benefit from this. Also, a very, very important side effect is here. You create secure audit logs of the integrity and trustworthiness of your device or whatever it is, network function, that can stay there forever and will ever be valid and provable, instead of the thing that you just convey with a nonce, which is only recent at a certain point of time. Next slide, please. This is hard. It is a rather complex mechanism. Basically, you prove that there is a time span on your device that is aligning with the trusted time source. You take your own timestamp from the local time, you cryptographically bind it with the external timestamp, and then again, cryptographically bind it with a local timestamp. This takes some time. And everything that is measured as evidence or via root of trust of measurement in this timestamp can be proven to be exactly made at that point of time, which is important and the equivalent to the nonce, effectively. So this document is effectively really mature, but it is a tad bit ugly. So the structure and layout needs improvement. We have 2 bindings included, which is an SNP MIP, which is mature and done. We have a Yang module, which we just derived from the MIP, which is therefore kind of broke, and we have to refactor it to make it actually like nice and beautiful. So also we need some better terminology, because this document is like over a year old now, and we will try to create new terminology here, and that has not been taken into account in the TUDA draft. So therefore it is using some terms that are misaligned with the things I just was telling you about. We will remediate this over time. It will just take time. And also at the moment we are conveying CBOR arrays as the elements. If an root of trust of reporting or a root of trust of measurement could natively create and sign a web token, then we could take CWT into account. But a lot of solutions out there at the moment cannot do this. So at the moment, it is a CBOR array, just like the X509 CBOR profile. The end.
Wow, I'm impressed. 28 minutes. So, clarifying question on the drafts. Can you clarify when you say mature and stable? What does that mean? Because they're not adopted documents.
They include running code and were tested by multiple companies in industrial environments.
Say that again,
They have running code that is not crashing. It is validated by industry companies today in their production environment.
Okay.
So this is why I claim, no, I give out the assertion that it is rather mature already.
Okay.
So relating to what you just asked, Nancy, Dave Waltermeyer, there looks like there's a lot of work that's been done here, which I think is great, but it's not clear after having a handful of presentations what work needs to be done next on these documents. And Hank, can you share maybe some thoughts on, you know, how, I mean, I came to this thinking this was the first working group meeting. Part of this would be about orienting us to how we can help.
Yeah.
How can we help?
So this were 5 minutes talks in essence all the time. So it's very hard to get to that point. With the Yang module, it is kind of very easy. You have to understand Yang modules and you have your own use case. If you don't find yourself in that use case and that Yang module, please speak out. This is the contribution we really expect. A lot of network vendors already did this. Maybe some other entities out there also want to have that in use and they're missing something, or they're identifying their root of trust for measurement differently, or the device component differently. If they cannot identify a component in their own network device with this module, it is useless to them. They would have to create an argument just for them, and it probably will never publish it because it's just for them. So this would be a thing to contribute now. With the time-based unidirectional attestation, there could be other applications to the scenario, like if you really want to have this data diode where you can only push evidence out of something and never talk back, so it's like a high security area or whatever. If you have the scenario, you're working in a field like that, please speak up and tell us, oh, this looks cool, but So this is the contributions we are working for, because these drafts are there for a long time already. They were here before this working group formed even, or was started to be formed, and therefore, well, maturity already is there a little bit. The architecture document, though, is the one that we really need input on. If you're unhappy with the composability, with the concepts provided, or with the terms used, that is very important. This is the most important thing to focus on now, I think.
I'm struggling with the arrangement of the sequencing you just described, and maybe I'm just hung up back on what I saw in the milestones. So what we're saying is, here are some very mature things that pre-existed kind of rats. They work. We should take them into the working group. But at the same time, we're saying we have this architecture. We got to talk about a lot. We're kind of not sure. But in the long term, we want these things that we want to adopt right now that are really mature. We want to plug them into the thing. We don't know what it actually is. It seems asymmetric to me. It feels like we should decide what is kind of the architecture and then figure out what we need to plug in that already exists or where we got to define new work.
This is the same problem as we had with creating the charter. We had to define terms without having a document that defines them. The same goes here. So everything that has to be used terminology architecture-wise in the solution draft today, the authors of solution draft should hurry up and get that in there now and bring it to discussion for their use cases. The information model therefore has not been complete in the end, and the architecture also not, but it has to be mappable as soon as possible. That is the solution that I would propose, that everybody who has something now contributes now, and if something is being developed and slowly integrated, they have more time.
Okay, so
I'd be interested to hear what the working group has to
yeah,
say.
so let me speak a little bit on the chair since I set up the agenda. So this is the first working group, which is why we wanted to make sure that we had, so your comments, Roman and Dave, are very valid. So we wanted to go through the charter. In the charter, we went through, this is the program of work. We need to define the architecture. We need to define an information model. We need to define the set of claims that we want to standardize. When we did the call for agenda, there is some work that has to be done. My opinion, having read through the drafts, is that some of them go more towards the interfaces. My question later, which I may cut myself off, is to determine which pieces you think are part of information model versus data model versus the operations on the data model, which is how I was construing the Yang module. So Roman's questions are very valid because those things really should come after we know the set of claims or attestations that we want to work through. Not that the work that you've done isn't relevant, it's the, are we putting the cart before the horse kind of thing?
Yeah, and that is okay. We don't have to do working last call necessary for a solution draft without the architecture. You put that in the milestone that way, but that is not the order we have to do it.
Well, we had to put milestones.
Yeah, so that's a template. I know.
Put it there just to get people's attention. So it's good that everybody's reading stuff. Okay, so with that, Stephen, I'm going to cut you off after that so we can get on to the next one.
Okay, so do you have time for my question? Or yeah, okay. So this was a lot of stuff, and I'm just trying to kind of contextualize all of it so I can understand it. Could you really quickly, and maybe going back to like slide 8, actually show the architecture? Where does TUDA fit in there? Like which piece is it? So I can understand where it fits in what you're imagining here.
Yeah, that one is good. TUDA talks between the attester and the verifier.
So
it does not rely on a relying party. It just proves to you with a yes/no quote in the end because it is based on an audit log.
So I don't see any connection.
Yeah, that's a composability feature I was talking about. You can draw on more lines. This is the A composition. Another composition was the collapsing of attester and verifier. As an example, you could collapse verifier and relying party, or you could do another edge that talks directly between attester and verifier, which I think in the TCG sometimes happens. Okay. And there's a bigger slide set. This is on the list before the working group called for consensus to form this. That is like 52 slides long and it includes exactly this diagonal line, for example.
Okay, so the composability is cool. It just doesn't help me understand what's actually going on here. So
Especially
something
with
that-
TUDA, in
TUDA,
general.
Yes, yes.
Right, I
Yeah.
mean, this is the first working group, so at the end, when we have time, which is why I'm trying
Yeah.
to accelerate the process.
We only have 2
is
hours. Sorry.
I'm believing that we're going to need an interim just to level set and get us going towards forward progress.
And note takers will have a lot of questions in their notes, so we can address them accordingly.
I think an interim's a fabulous idea.
So again, interim good, yeah, okay.
Okay, you're
Yeah.
done. Gary?
In time.
Thank you, Hank. Yes, and you did it in time.
Okay. Thank you. I'm going to try to see if I can give 5 minutes back to Lawrence because I know that discussion is going to be could be quite long. So I'm going to introduce the topic of attested TLS token binding. This is based on a draft that I've had in the TalkMind group for a couple of years now. I'm not going to really do justice to the topic of token binding itself, but the first 2 slides are about this. It's basically token binding came about because of vulnerabilities in identity federation system tokens. If a token actually gets extracted from a client, then those tokens can actually be used to spoof on behalf of the client and fool relying parties. The tokens could cause vulnerabilities to man-in-the-middle attacks. And as a result, the IETF a couple years back started the whole TalkMind effort. Now we've had recently 3 RFCs approved that describe how token binding the token binding protocol and the TLS handshake requirements. Go to the next slide, please. So token binding currently consists of first off negotiating token binding between the endpoints, and then passing a token binding message, an HTTP bound message that actually signs over a payload unique to the TLS connection, primarily the exported key material, the EKM. Right now, the implementations in browsers, they basically all the implementations out there have the browsers maintain private keys associated with the TLS token binding. Those browsers, user agents, I use the term interchangeably. They're implemented in user space, and as a result of that, those keys themselves can be vulnerable, and you're back to the same problems that token binding was designed to actually address, which is extraction of private material from the client by hostile parties. Even if you go away from browsers, a lot of there's proposals to actually implement TLS token binding in what we call native applications, like Android App Store applications and such. Many of those applications will be relying on open source code like OpenSSL. And therefore potentially be exploited if attackers can actually if attackers can actually extract keys from these libraries. Once again, the primary vulnerabilities are running in user space. Please continue. So I'll define what I call hardware secured signing for TLS token binding. So these are my definitions alone. You can take issue with them. I don't mind. I've defined what I call a signing process, and it's just any application or any kind of platform functionality that can execute a crypto operation such as signing, so that the browser can actually delegate to that. So hardware bound or hardware secured signing would actually run in the context of what we would consider a root of trust. Examples of root of trust are not just TPMs and secure elements, but also trusted execution environments as well. So such processes can be used for generating a signature for token binding, and the relying party, in this case, can make decisions as to whether to continue a TLS session with the client based on security assurances related to storage of the private keys. Well, how does the relying party make that decision? Please move to the next slide. remote attestation. I have a definition here. I don't want to go through it because I think we've talked about it not just in this IETF meeting, but in the previous two, and I think Hank actually did a decent job of saying how a relying party and a verifier play into consuming an attestation statement generated from the device. Now, one of the things that's actually been a little bit challenging for browser vendors to actually implement carriage of attestation data related to hardware secured private keys for token binding is performance. They're very worried not just of the TLS handshake, but anything that can affect HTTP performance even post handshake. And verifying the token is already, the token binding message is already tough enough. Now you're talking about verifying an attestation statement as well. So these are some of the things that I've run into, and I've run into several different options as to how to actually do this in such a way that that takes into account the performance considerations. Can we go to the next slide, please? So the token binding, the TalkBind group actually wants to see attestation and wants to see a solution. They defined an extension mechanism for TalkBind messages, and it's specifically cited in 8471 that the intended use is for attestation. The ID that I have currently proposes defining a unique extension for each attestation type. In the current draft, I put in an Android key store attestation, the TPM version 2 compliant attestation, along with the corresponding verification procedures. We can also, if the group decides to do this kind of work, and Hank also mentioned this in his presentation, we can certainly look at other different other attestation types as we go through the definition. More importantly, I think we can also look at how this can be conveyed. So this is, does it even make sense to define a different extension for each attestation type? Should we just define one extension for all attestation types and build it and put in sort of an in-band protocol within that extension type to actually describe which attestation is being conveyed? Let's move on. Yeah, okay, I'm almost done. Can we? Yeah, next slide, please. So, why take up this topic in this working group? Well, a TalkBind private key provenance is not really being verified by any relying parties today, and attestation is one way to do that. And also, I've read through the charter again, and I believe it is covered by the program of work as far as standardizing interoperable protocols. And I think we've seen some recent contributions where you can actually see some value in if we can actually bring the attestation data in a TalkBind context. For instance, the ARM, the contribution by Hannes and his colleagues at ARM on the PSA token actually mentioned something called software competence. Well, what if one of the things that we could call a software component is the browser itself? That could actually be quite useful to the relying party as far as their determination of what can be done with a particular TLS connection. So my last slide. So this is my last slide. My recommendation is that the RATS working group take on an effort to define TalkBind extensions for attestation. I volunteer the draft that I have in the TalkBinding working group as a starting point. Doesn't have to be, but I think we can include this in our program at work, and based on that, we can determine initial attestation formats. Going from the use cases that the use case document that we discussed at the beginning of the meeting. And that is all. Thank you.
Thank you. Make it quick.
Yeah, hi, this is Hank, making it quick. I'm following this work since 00 because I am aware of everything that uses CDDL, but I have a chance of you were using that. Also, I'm in favor of this idea of creating a attestation formats meta header so that we don't just have one protocol here that is basically in the talk bind definition and not, I don't know, for everything, that we can make that extensible. I don't know how much overhead that creates effectively, but it sounds like a very good idea to pursue and test out.
Okay, thank you. One of the things that browser vendors actually said, and this is even related to our FIDO experience, is they want the ability also to not send an attestation at all, at least have the relying party have that capability. So I think that's one of the things that I think we will need to figure out with TalkMind is how do we actually do that in such a way that, how do we actually enable that capability in such a way that the client isn't sending attestations when the relying party in certain cases doesn't want it. And has no use for it. And it's not just because they have no capability to verify it. They don't want to take responsibility for device identifying information. Maybe a privacy issue depending on the nature of the service. So that's another thing that when we define these in-band protocols, we should consider a mechanism for that. Right.
Okay, thanks. Next, we have Lawrence with EAT, and then discussion.
Hello, next slide, please. So I'm going to first describe EAT as it sort of exists and is written up today. Not really saying too much about what, and I expect it to change and expand and morph a bit as it becomes part of RAT. So my first explanation is just really kind of how EAT was created. And for folks that have been to the BOFs and others have probably seen some of these slides already, but I'll go over them quickly here. So this is very top level. The idea here is you've got some good devices, lots of different kinds of devices, and you got some bad devices. They might be trying to emulate a real device. They might be tampered with. They might be cloned, or they might be rooted. So we're trying to collect a bunch of claims. I've used the term claims. Comfortable with that until we actually settle on have agreement on another term. So I'm going to stick with the term claims for my discussion. So you collect a bunch of claims, sign them, send them to the relying party, which could be, this represents some use cases, banking use case like a risk engine, some IoT that's back end that's trying to determine whether it's a real device or not, network infrastructure, car components talking to each other, cars talking to each other, enterprise, or public utilities. Kind of use cases. Next slide, please. So this is, Hank kind of referred to this slide, and I think there's some reasonable alignment with the 4 boxes slide here, with Hank's 4 boxes slide. But the basic idea is you have a device. We use the term entity because we wanted it to be either a chip, a device, a subsystem, a car, a refrigerator, just very broad range, or part of a refrigerator, part of a car, very broad range of things. That's why we use the term entity there. And it has the ability to collect claims and sign them. Those claims, that group of signed claims is a token. The token is transmitted to the relying party, and then the relying party verifies it and looks at the claims and then makes a decision about what the relying party is going to do. So the relying party, may care more about the geographic location than anything else, because they're going to look at that in relationship to other financial transactions that that particular user has made, and realize, well, if he's 10,000 miles away from where the last one was and it's been an hour, something's wrong. It could be a decision in that vein. So, EAT was very interested in, is very interested in the claims, standardizing claims. It seemed like the low-hanging fruit and the most interesting thing to focus on first. So that was why we looked at that. And originally the vision for EAT was the claims going from the entity to the relying party. As we saw with Hank's diagram, we can expand that so the claims can go other directions on other interfaces as well. I thought that was a reasonably good idea and way to characterize it. Next. EAT is basically, the proposal was basically to use a CWT, kind of repurpose it. Had a lot of really good characteristics for the IoT world and similar to stuff that was done in FIDO, and not really a fan of ASN1 myself. Jose or GWT was a little bit large for IoT devices, so CWT seemed like a really great fit. I don't think I'm going to go into any more on that. It's basically COSE format message there. So one of the things that we thought about with EAT in terms of signing schemes, like how the classic way to do it would be ECDSA signatures, but in my kind of understanding of IoT and some of the other issues there, we really do want a lot of flexibility in the signing scheme because it goes to complexity in chip manufacturing. There's also privacy issues with signing. So we might want signing schemes that are privacy preserving like ECDAA. So we start with things like ECDSA, but even symmetric signing would be reasonable, or other things like ECDAA. And you know, COSE gives us the flexibility for all of those sorts of things. And it seemed a bit scary to try to standardize on all of those because there's a lot of use cases and a lot of variations there. So just the moment leaving those things open and let COSE handle that. Next slide. Here's an example token. I think most of us are familiar enough, so I'm not going to go into that. It's just an example of a CWT. Nice and small and compact. Next slide. I want to mention privacy. It varies a lot by use case. In the case of something like a light bulb, which really only has one user and one use case and very simple, the privacy issues are not very large. If you're talking about an attestation for an Android app where you might have a lot of claims and you have a device that talks to dozens, maybe hundreds of relying parties, and correlation between that relying parties for that device is a big issue. Privacy becomes a very big issue and has to be handled carefully. So my example here, you know, a light bulb might be something with 2 or 3 claims. An attestation of an Android app might have 100 claims. So, you know, how do you handle privacy? 3 options really, I think. You omit privacy violating claims. So you just don't have them. You redesign the claim so that it can work with privacy regulations. And I think I have some ideas how to do that on some claims. Some claims it'll be easy, some claims it'll be impossible. Or you ask permission. So classic example is permission to use location in an Android app. Then, as I mentioned, also signing schemes. If you're doing one key, every individual device has a unique key. Just the key itself becomes a device identifier, and you have a privacy. You may have a privacy problem. For example, in FIDO or Android attestation, you definitely have a problem. So you can't just do one key per device for FIDO or Android. So that's why you might need some solution that, like ECDA or group keys. Next slide. So I'm going to finish this. I think this is the last slide, and then for this presentation, and then I'll maybe a few questions, very brief, and then I'll go to the next one, which is more about claims definition. So EAT defined basically this set of claims. This is a high-level description of claims. This was an initial set. This was getting started. It seemed like there would be lots of claims we can spend a lot of time on, and that I was anticipating that this work group would spend a year or two defining lots more interesting claims. That's really the sort of some of the meat and potatoes work. I've started a categorization scheme for claims that's just trying to chunk them into, like, okay, let's work on this group or work on that group. So I started listing that on the right. So there's some basic claims, which are things that are kind of standalone, simple. And then some claims related to submodules where you have one device that has a submodule, which might have another submodule, and how devices are put together. There's a lot of, a modern cell phone has a lot of different subsystems, so many of them which are interested in attestation. So the next slide deck, I'll go into a little bit more about the areas for the claims and what to do about them. So questions?
Hi, Robin Wilton. Could you just go back one slide, please, Lawrence?
Back one?
Okay. I just get uneasy when if there's an implication that the potential privacy impact of a device or a given attestation is a factor of how many of them there are. That's clearly a thing that may only expose 2 or 3 claims could be devastatingly privacy invasive. So the implication there that there's just a purely quantitative aspect to this makes me nervous.
Yeah, I didn't mean to imply that. Thank you.
Brendan Moran. I just want to object to the idea that single-use IoT devices are less complex for privacy. I don't know how much it overlaps specifically with attestation, but just to give an example of where this falls down, things like lights, IoT lights, which are single use and supposedly simple, have been used to harass ex-partners after breakups. So just because they're simple does not mean the privacy implications are not significant.
Okay. Sure. Okay, let's move on to the next slide deck here. Next slide. So in the work on the charter, we came up with the idea of an information model document. My understanding of that is to be a document that defines the claims that can be in a token. We've had some back and forth and discussion, side discussions and stuff about whether the syntax of the claim is defined in this information model document or not. I know we certainly want to support more than one syntax, so CBOR-based and JSON-based, and maybe others. So I'm sure we want to describe the claims in a syntax or serialization neutral way. Certainly we have to do that, and then we also have to define how you serialize it in CBOR or in JSON or something else. I don't have a super strong feel on where those things all go, but to me what's most important is we do have an informational document that's neutral, and a description of the claim that's neutral for serialization, and then we do the specifics. So this, when I made this slide, I was assuming there would be separate documents, but I've had some other discussions where maybe, because some of the serialization descriptions are going to be really simple.
So Roman Danelli, I just wanted to jump in on exactly that. To your point, I mean, the charter doesn't explicitly say they have to be separate documents. There is prior precedent to having an information model in a document, then a data model that aligns with that, and then another data model that just references the information model kind of portion of that. So the working group can decide what makes most sense.
So if I had to pick now, I'd say let's put it all in one document and see how it goes, and if we don't like it, we can split it.
Tony Natlin, are you also pulling in JWS and E also?
I'm sorry,
are you pulling in the signature and encryption also from a JW,
Yeah, I would assume if we're doing JSON style claims, we're signing JWT format, and CBOR style claims, we would sign CWT.
I just want to make sure you're considering encryption and signing.
Yeah, absolutely, yeah. But I opened, how we want to do this. I mean, I think there's some options there, but that was the assumption. Okay, next. All right, so I actually wish I'd spent more time making a fancier slide here on these, because I think this is probably the kind kind of some of the core discussion here. I'm going to start at the bottom of this slide. So the vision I had here was that all claims are optional. There's no mandatory claims at all. Just seemed like it was hard to come up with any particular claim that was absolutely mandatory. Maybe in nonce, but now we have TUDA, so maybe not even that in the same way. So and this is, for many use cases. Now you can have profile documents that say, for this use case, you must have this claim, but in a general way, all claims are optional. Next one up from the bottom here, the idea is that claims should be generally applicable, so they're not specific to TPMs or trust zones or SGX or Android or Linux or Mac OS or whatever. So we're really trying to make the claims as general, thinking about the relying party as the audience. So the relying party could be lots of different things, and they're going to be getting attestations from lots of different types of devices. So it's up to we want to make it so the relying party can figure out what's going on. So that really the audience for the claims is the relying party. Similar, I think it should work, the claims should work with different levels of device security. So sometimes the attestations are going to get generated inside secure elements and TPMs or smart cards. Sometimes they're going to get generated by an app running in Windows or some very low security device or something with no special characteristics at all. So to me, that's an important thing. We're going to spend a lot of time thinking about claims in TPMs and secure elements, but I also want to think about those claims coming out of other places that don't have the same security like that. Okay, so now the 5 areas I'm proposing for claim definition work. I wouldn't consider these particularly sacred, but it seems like a really good starting point. So there's basic claims, which things like the identification of the device, the identification of the who made the device, the position, location of the device, what state did it boot in, and things like that. Typically, these are simple, unstructured claims, and this is what E has defined a number of already. So that's one group. Next would be a description of software components claims. So these are, I've looked at Cisco's big giant file of software components and some work done with ARM. There's a list of software components in the PSA design, and as you know, there's the other working group that I think it was SACM that has done some work here. I think of the software components claims as describing software that was released by an organization that is to be installed. Not running software, not the software running on this TEE, not the software in this application, not this operating system. And an interesting example to me is like a library that's released, it's a simple library that gets dynamically linked into the TEE, because it's such a general library like, I don't know, string compare, it gets linked into the TEE kernel, it gets dynamically linked to a trusted application, gets dynamically linked to an Android application. Same thing, right? So the software component describes the library, not where it's running. So that was my thought on what software components were and how to structure them. They might have a name, they might have a hash, they might have some other characteristics describing some type or something like that. So it's almost like you could imagine a subgroup of us going off and say, we're the software components subcommittee and we're going to design those claims. Thinking about all the different use cases. So that's the second one. Third one is measurement and integrity check. So this is now you're trying to look at running software in a subsystem and see if it's the software you think it is. You might be reporting the hashes TPM style. Integrity check is a different kind of architecture. I mean, I think most people are familiar with the TPM style. Samsung has a product called TIMA, where they run an integrity checker in Trust Zone that checks the integrity of components of Android. And it reports a yes or a no. It doesn't report a hash because Trust Zone is isolated from Android. So Trust Zone can measure something because that's outside of Trust Zone. And Trust Zone in this case has the correct measurements, the known values. It knows what it's supposed to be. So that's a different style of integrity measurement, and there's real world products, at least one or two or three, that do that. So to me, you want to include both of those. So that's the third one. These are somewhat, I'm sort of listing them from easiest to hardest as well. At least when I worked on, thinking about the designs here, the ones that I thought were easier and harder. So fourth one here is public keys and the characteristics of those keys. And the really good example is the Android key store. I sent a link, I think, to the mailing list like 2 hours ago that showed basically all the claims that an Android key store makes about a public key. And there's a bunch of really interesting things. I think I've also seen these kinds of, let me back up a minute here. So the idea is you put a public key in as a claim, and then all of the other surrounding claims tell you something about that key. Like it tells you that that public key is running on a device that was booted in a secure way, or that public key is, and the corresponding private key is in a device that we did a measurement of the Android kernel, and it's this, so you kind of know something about how trustworthy that key might be. So you put the public key in, and in the Android use case, the Android app can tell the server something about how the keys are stored. I've seen public keys embedded almost, or a CSR being embedded in the token as a way to set up a key agreement or provision keys for IoT use cases, or what's a DTLS. So that's in this category as well. And FIDO, in a way, is in this category for the FIDO registration step, where you authenticate the user, and then you generate a key pair for the combination of the device, the user, and the relying party, and then you attest that key and send it to the relying party. So public key and maybe even CSRs. I mean, this is going to start tending in towards ACME and some other things too, which I don't know very much about, but so that's another area. And then the final area, submodules and nested claims. So you can imagine you can start with a chip that's in a module being a circuit board that's designed to do some particular little thing, that's integrated into some sort of a box like I don't know, ABS system and an anti-lock brake system in a car that's integrated into a car. So now you got 4 layers of nesting. What's the attestation there? Do you use the chip to attest all the layers up, or what? So another thing is you do attestations inside Trust Zone, and it can attest to trusted apps, to the Android kernel, to Android apps. So that's all how you dealt with modules and submodules, and it really gets into device architecture. So it seems like the hardest one and the one I've struggled with the most. How am I doing on time?
We can give you 10 minutes. I mean, I'd like to get the Q&A.
Yeah, okay. So I think the next slide. So I want to just show a couple of claims that some of the details of a couple of claims that were defined in each. Nonce, that's, I think, very straightforward. Yeah, so universal entity ID. So this is one we've spent a fair bit of time trying to define. It's like a serial number. It identifies an individual device, chip, box. If you've got 1 million chips, you've got 1 million different IDs. So not a model number, not a device class or anything like that. So this point here then, that it's universally and globally unique across all devices from all manufacturers, that's really the key characteristic here. We didn't want it to be qualified in any way so that a relying party receiving one of those things, no matter what kind of device, where it came from, what manufacturer, can trust that this thing is truly globally unique, and they don't have to do any extra work in their database to say, okay, yeah, these unique IDs are from Samsung, and those are from I don't know, Ford, and those are from Infineon, the chip vendor. They don't have to qualify any of those. So there was a design attempt here to try to do that. A couple different types, one based on just a GUID, a large random number, another based on IEEE EUI, which is basically a MAC address, and then IMEI, which is common in the mobile phone business. So I'm mostly giving this as an example of how some of the thinking is around claim definition. I mean, I think this one is fairly complete, but I'm sure we'll have lots of discussion about it. So, question about this one, or?
Yes, this one specifically. Sorry, this is Brendan Moran. Is there something that was missing out of RFC 4122?
I'm sorry, what?
RFC 4122, a system for creating universally unique IDs?
I haven't looked at that, so I don't know.
Okay, I just was wondering if there was something that wasn't covered in it.
Maybe we should just reference that.
4122, yeah.
Okay.
Thank you.
All right, next slide.
And Kathleen Moriarty, pretend I'm over there. I'm also just worrying about the identifier type and privacy implications. Because anytime you have an identifier, you have to worry about that.
Yeah, absolutely. Yeah, yep. All right, so identifying an OEM. So who made the device? Did they could be the maker of the chip, the circuit board module, some sort of finished product, even a larger aggregation, right? So the proposal in the EAT was to use IEEE OUIs because IEEE does do a global registry of companies. Basically, it's the first part of a MAC address. There is some entanglement with IEEE because you've got to pay for those, so perhaps we can use a GUID here as well. Go ahead.
Just for information, this is Brendan Moran again. In suit, we are using, or we are recommending RFC 4122 GUIDs derived from the vendor's domain name.
Okay. Okay, sure. So, next slide. So this was a attempt at a design to describe the boot and debug state of the entity creating the claims. So the first, is secure boot enabled. Basically, that's a Boolean. It seemed like that was enough, at least from our thinking in the TEE world. I know some people say secure boot and trusted boot, and it means different things, and I'm sure we can have some discussion about that. My intent here, though, was, and I think a lot of that comes from the TEE world being different from the TPM world, where the TEE world, the end user cannot install software on the device. You really kind of lock that down. The OEM kind of locks that down. So, and in some ways, it was simpler. So the main idea here was if secure boot enabled, that means the software was authorized and by the OEM, and that's the only software running. And then debug state, really four different states here, going from a full permanent debug disable such that not even the OEM can re-enable debug. And this is thinking also from a hardware point of view. Like ARM core site hardware, debugging hardware is really powerful. It can look at buses and all sorts of things. So disabling that is, it matters, right? So permanent debug disable is such that only the OEM could and re-enable debugging, and that might be an RMA situation where they're trying to find out why that chip is failing. And then disable since boot, and then just generally disable. So that was enough to just to give a flavor of some of the way the claims are. I've been thinking about the claims. So I'll stop there and we can have discussion.
Thanks.
Ned Smith, Intel. So in thinking about the information model, I think there's several options that we can consider. There's some, and I think this is the heart of the hard problem for information models. Essentially, what we see with the examples with TPM and key store and so forth is an example where you have a vendor or a standards body who have gotten together and defined the information model already. So TPM attestation information model is done, and so we have some. So this gives us some questions to ask ourselves and how we want to move forward. Should we have a situation where we're going to define a set of claims or assertions that are essentially a mapping from a semantic mapping from an information model that already exists but isn't done by this standards group? And so we need to do a mapping from one information model to another information model and potentially back to another information model if you're trying to get complete semantic interoperability. Or another choice is we could say, well, let's not try and do the mapping, but let's just make it easy to be able to convey information that's represented in an information model that's already defined, but more focus on the interoperable representation, but not on the semantics of the information model, right? So this gives us, so that sort of points us in a direction of focusing more on, say, what a manifest structure might look like to be able to represent an information model that's already defined somewhere else. So that's one hard problem. Now, another problem to consider is, well, what if somebody who is building a new system and hasn't defined an information model, do they go to the IETF for help in providing the building blocks for doing that? In which case, we could define an information model with a bunch of sort of useful stuff, but not try to pin it down necessarily to any particular structure in terms of how the system is put together, what the various components are, what the nesting looks like, what the software pieces look like, but provide sort of just useful parts, and then define it in such a way that the sort of designer of the system could put those useful parts together using just IETF defined stuff. So that's two sort of important questions that we should think about when we are thinking about information models.
Gary Mundium, Qualcomm, and just want to give a partial response to that. I think, you know, I can say, for instance, with the early versions of EAT, we did examine the TPM model. I think I'm kind of glad that we didn't bring in concepts such as measured boot into this, because I think that we would have benefited more from actually getting the group's opinion as to how that could actually best fit into the information model. We're not necessarily trying to supplant existing ecosystems. I think in this effort, we would actually try to leverage that as part of the overall information model that we come up with in this group. And I think even, and we would actually want to augment the existing attestation ecosystems too. I mean, I'll give an example with FIDO Alliance, right? I mean, we do have TPM attestation there, but it was necessary for our particular use case in defining the FIDO 2.0 spec to actually augment it in the form of a CBOR type structure around that was built around the TPM attestation format. So I could envision, you know, for instance, like a location claim being used to augment a TPM attestation in a similar fashion. So I think it is possible to meet to address your concerns, if I understood them correctly, Ned.
Lawrence Lundblade. So I think to talk to Ned's point there.
Can you speak up louder, please, Lawrence?
Yeah, okay. So to Ned's point there, in some cases, there's going to be pre-existing things that are really easy to reference. I think like position location, I believe there are already things. So that's it's sort of a slam dunk, and we should use that. We would be very silly and foolish not to do that. To me, a lot of the hard work and interesting work here is to try to come up with an information model that is universal. And I'm really thinking about the relying party here, where the relying parties are kind of all sorts of different things. You know, they might be a credit union or a bank or an IoT backend or something. But the more we can come up with universal claims that any relying party can pick up and know what they are. They don't have to go read the chipset spec to know what the bit fields in this chip mean, or understand how this particular module vendor interprets this particular field. The more we can be universal with the claims, the more powerful and useful this is. And really, I think that's kind of a critical orientation that we should adopt here. I know it will be hard, and I know in some cases it'll be really hard, in some cases we'll fail. There will always be the option for a vendor to put claims in of whatever style and shape and size they want to put in. Maybe we have some IANA registry for dealing with all kinds of new claims. But I'm really very interested in coming up with a standard set of universal claims.
So just to make sure I understand, Lawrence, you're speaking in favor of creating an information model that puts a structure into which new claims can be mapped to some semantic interpretation, and that is platform agnostic. Is that?
I guess the information, well, I'm a little unclear sometimes what the term information model means here, but I mean, my suggestion here is we actually create a list of standard claims, 20 claims, 30 claims, something like that, that we in this group say, this is what this claim means. And if you receive this claim, you should be able to trust that that's what the vendor intended by that. And those claims will be done in a platform and vendor use case and industry agnostic way.
Okay, so to regurgitate, you're suggesting that the group work on a set of claims that we put structure and semantic meaning on, as well as the interfaces to allow for the interoperability, and then potentially protocols to relay communication, as in transport or transfer.
Yeah, I mean, to me, the claims are all bundled into a token, so and signed. So it's the transport and the method of securing the claim is sort of orthogonal to the semantics of the claim. And so it's also kind of the beauty of using COSE, and that you can define the claim for position location, and you can sign it with ECDAA, or you can sign it with a symmetric key, or however you want to define that in COSE. But they're really orthogonal. The method of securing the claim and the method, the semantics of the claim is orthogonal. So.
Right. And that's why we've decoupled, if you look at the scope of work, we decoupled the information model from the actual interfaces and, right. So coming back to the information model, you're saying let's just define a set that have a standard semantic meaning so that as they get carried through the different interfaces and protocols, you can get interoperability. Got it. Okay, Hank?
Yeah, exactly. Hi, this is Hank. I'm okay with defining a lot of assertions/claims. That's fine.
there were some other things in your slide sets, for example, software components, you were calling them, and I'm not sure if you can define them via a claim. It would be a huge value. I mean, you can put a software identifier tag as a value into a claim, or even complete manifest, then that value of that claim would be gargantuan. I'm not sure if that is the intent of the claim in CWT, but it is discussable. Also, there is, for example, the integrity measurement architecture today in every Linux system, and they create measurements from staging the execute. And I'm not sure if you want to put all of them in a single claim or in a claim set. Again, that would be gargantuan. So some things I think are valuable to be defined as a type in the information model, but I don't think they will up being claims.
Okay, Hank?
Yeah.
I'm going to speak for Lawrence here. He had the categorizations, and where he had the submodules, it's how do you nest claims?
Yeah, so that's why I think that software modules. I know of these, and IMA was not in there, and I think those might not be claims. They're an information type in the information model. They might be a huge type of assertion, but they are probably not claims.
Brendan Moran here. I just want to speak to the sort of interaction between software composability and privacy. And I think that there's a fundamental assumption I've seen in the slides. Maybe it's covered elsewhere in the documents, I'm not sure. But it seems to assume that there is a single verifier in the system. And I'm not convinced, just bear with me for a minute. And I'm not convinced that's true. And Hank tells me that it is in fact not true, so that's good. But there's something else that goes along with this, which is that there may be a need for ensuring the privacy of certain claims with respect to a given verifier and the privacy of other claims when sent to another verifier. So it looks to me like there's actually going to be, or need to be, some kind of structure to establish a secure session, if you will, between each of the subcomponents and its equivalent verifier.
I agree.
Hi, this is Hannes. To pick up on what Lawrence said, so I think if we could spend some time in the working group to discuss what the semantics of the claim, the sort of a standard set of claims are, that would be very useful, in my opinion. And I don't want to go into the details of what the software component claim does, but we are using that in the PSA, in our PSA attestation token, but we can change the name and we can also change the semantics. But there's an example for that. In terms of transport, that's of course a separate decision, but as mentioned, sort of there's some focus on the CBOR web token because of its size. Maybe others want to have a more JSON web token, but I think the number of formats that will be then dumped into protocols will be rather limited. At least I hope so. And they can be then carried, as Gary mentioned, in a couple of these different protocols. They already have some containers envisioned where we would put them. So I see that as a rather straightforward process and shouldn't be too complicated. The separation between information model and then the serialization, that's something that looks like a great idea, and putting them in a separate document, like in separating it out conceptually, I think is useful, but then moving it necessarily out into separate documents, I'm not
We haven't gotten there, Hannes.
Hmm?
We haven't gotten to, is it one document, is it multiple? But I hear your point.
Dave
Okay, I'm going to cut line off at Ned.
Dave Waltmeyer. So maybe one way of thinking about the claims problem is not directly trying to tackle a standardized set of claims, but instead to develop some framing around how claims can be standardized. So, what I'm thinking is maybe an IANA registry of claims, so that within that namespace, it can be partitioned so that vendors can have their space for claims that we could have, standards track claims that may represent that, that standardized set. Really getting at sort of the structure around how to define a claim. Maybe that would be the information model, and then instances of those claims could then be expressed in a data model and exchanged as an idea.
Yep, that's a valid point.
So as to what is a claim and what is not a claim, the way I was thinking about it was basically any sort of member of the token is a claim. Even if it's huge and complicated, it's a claim. And big, complicated, nested claims, a claim with the substructure with arrays and maps as a part of it, it's still a claim. And so it may be ugly and you may not want to call it a claim or something, but I would still call it a claim. And I just also point out, like the Cisco known good values thing for describing software components is really simple. I think it's just a name and 2 hashes. So that seems useful. So that's, and the definition of a software component that PSA took is, I think, has 5 different fields per software component. So there are examples of software components claims that are reasonable. I don't know if we come up with something universal. That may be difficult, but anyway, so that was just to the point that anything that's part of the token is a claim. That was the way I was thinking of it.
Ned Smith, Intel. I want to throw out another, what I think is a hard problem. This has to do with the sort of the starting point for the data structure that we're relying on for interoperability. As I think of this as a manifest as the starting point. However, in the Tokebind draft, the starting point is the TLS message of some sort. And if you look around in other places, there are other assumptions. Like the assumption might be that it's a COSE structure is the starting point. If we look at just within IETF, there's several different manifest structures out there to choose from.
Get
TCAS
closer
one.
to the mic. There's fans right above us.
Okay, sorry. So if we look around just for manifest structures, there are several different manifest structures in different working groups within the IETF alone. And so there's some question of, can you nest manifest structures? And I think that's being done already in suit. So
Ned, are you suggesting that
this group should have an
there's
opinion?
nesting already in manifests?
There's nesting semantics and manifests already.
Okay.
But this group needs to have an opinion on where's the starting point.
Okay.
Okay.
So you're not suggesting that the manifests that, for example, that we work towards manifests, because that would be building a tight dependency, I would think, with suit.
I might be suggesting that it seems that as we have some of these discussions about nesting of claims, I think what's really going on is we're saying we have to be able to describe the complexity and richness of things. And so those things are combinations of hardware and software and whatever, and they tend to be, complex and nested and so forth. And so we have to have structures that can deal with that complexity. And I think that the complexity that we see in manifests exists because they're trying to replicate, what's really out there. I don't think that we get away from that just very easily. And I also think that within the context of where you are in the system, or in the component, is where the claims are relevant. So, for example, you might have a system with a TEE that has some strong security assertions, but if the claim was associated with the platform surrounding the TEE, then it would be a security mistake if the verifier assumed that property applied to the entire system and not the TEE.
Okay.
Okay.
Okay, so I had cut the line, so can you be quick? Is it a quick comment?
Yeah, so it does. I was just thinking that whether RFC 8225 will be applicable here, because there is an INR register and passport is actually defining that and a lot of nested claims are actually defined there. So, and also an INA registry is created based on the different claims. So I don't know that RFC 8225 will be applicable there.
Yet another thing that we need to review. Okay, so we've got 5 minutes left, so I want to discuss next steps forward. So just for interest, let me get the list. Yeah, I want to get an indication. Yeah. Can I get a show of hand? How many people have read the EAT draft? Well, actually, a fair number. Okay. How many people have read the token bind draft? Oh, my. How many people have read the interaction model draft? It's the same people. All right. Minus a couple. Okay. What about the Yang module draft? Okay, a little less. And the TUDA draft? Oh, and less still. Okay. So there was some discussion about having potentially used the EAT draft as a starting point, as information model and an example of how you carry that using CWT. So in the interest of time, I don't think I have, should I do the interest here? Or?
Yes.
Okay, she says I have a couple minutes. So can I have a show of hands, because I can't hear anything with the fan. Can I have a show of hands if there's interest to have that draft be adopted as the starting point for the EAT draft, as the starting point for information model and potentially example of a data model? Can I have a show of hands, please? Okay, I get 8. Huh?
I missed somebody.
How many did you get?
Did you say 12?
Oh, and over there, 4.
Okay, sorry. I missed some up here.
I still get 9. Okay.
We can't see and we can't hear. This is a bad location. I can say it at the mic too, so it's recorded. Who would be against the EAT draft as a starting point? Show of hands? Okay, very good. So we can take this to the list to confirm.
Should we do the same thing for the architecture, since we have
Sorry, I have to ask a question. We were talking about an information model draft that is not on this list because it doesn't exist yet.
We
So
can't adopt something that hasn't been.
Right, we can't adopt it, and so
Yeah, of
I
course,
asked the
yeah.
question if you would
As a
be
starting
willing
point,
to
okay.
adopt the EAT draft as information/example.
Yeah, we have 2 minutes.
Frank Xia, I'm not against it as a starting point, but I mean that I'm not sure whether that specific use case based solution can be
Okay,
a very
so-
general one to represent all the solution or all the information model.
May I suggest that we as the chairs will post it to the mail list to confirm, and so you guys should voice concerns and opinions, because if there's enough negative there, then we won't adopt it. How's that? Okay? Okay. Similarly, there were quite a few shows of hands on the token bind draft, but that's more of a data model. So without an information model, I don't know. Oh, sorry, see, it's late in the day. It's a virtual Friday for me. So should I ask the negative or the positive to adopt? How about, are there any objections to adopt the token bind as a protocol binding starting point? Any objections? Going once, going twice? Okay, we'll confirm that in the list as well. Okay, last question.
Do they support, let's see, do they support it though too?
Well, I asked
If they read it, it's different than if they support it.
But
So reading is different. I think it's useful just to get a show of hands if you support it.
I'm sorry, at this point, I don't remember what was the number about how many people read the token binding draft. Was that the number? There was a lot?
Yeah, yes, it was a lot.
It was a lot. Actually, it was more than 12. I'm just nitpicking, so there.
Okay, so I think it's worth asking who supports adoption.
Raise your hands, please. Who supports adoption?
Keep your hands raised.
There's 8. I get 8. Oh, 9. Wait, 2?
Doesn't count.
Yeah.
No, that doesn't out.
So I get about 8.
So we can take it to the list.
I think we need to take it to the list. And honestly, at the interest of time, I mean, we're over time, and I'm concerned we're trying to really compress these kind of adoption calls without discussion.
Okay,
We
so
have to defer.
we don't have time, but I'll give you the heads up. We're gonna see if there is enough interest. I think we really should have an interim. So I will put that to the list, and hopefully we can do something in the April, end of April timeframe.
Okay, and blue sheets, could you please bring up the blue sheets and sign them if you have not yet? Thank you all.
Thank you, everyone. Blue sheets up here. Where's the second one? Did everybody sign the blue sheet?
Yes.
Yeah, David's coming. No, it's a Roman or me.